video, we'll be looking at torque, moment, and angular momentum. These are the main things that will be concentrated at. So the first thing, before we go into detail, the first thing that we look at, it is what we call the torque. So we need to define what a torque is. So torque is a product of force. So it's a product of force and what? The product of force and distance, or I can say perpendicular distance. So let's say perpendicular distance from the rotation axis. So this is from the rotation what? Axis. So if I say torque, it is a product of force and perpendicular distance from the rotation axis. That's what we call torque. Now, this means that torque, it is an effect that causes an object to rotate. Why I'm saying so? Because if you look at this, like that. So here, that's where the object is rotating, or I can say this is where your pivot is, or the rotation that is taking place. And this side, that's where you are applying the force. So the distance, which is from the point which is rotating to the point where you are applying the force, it is what we call the radius. So that's a distance, the perpendicular distance that we're talking about. And the force that is being applied, which is here. And this force is being applied at a right angle, like that. So if you check this, you shall see that you have the radius, or the perpendicular distance from the applied force, which is this part. And this product, it is what we call a torque, or an effect that makes these two things here to be rotating or to be moving. It is what we call torque. So I can say torque, it is more like a rotation at a what? Fixed point. So that is what we call torque. And this torque, what you need to understand is that every time the force that is applied here, it is supposed to be perpendicular. So if the force is perpendicular, the formula that we use when calculating the torque, it is what we call torque is represented by this symbol equal to force times what? Radius, like that. Or I can say torque is equal to force times radius, then I have to say sine theta, like that. So these are the main formulas of torque that you need what? To take place, or that you need to be using when you're dealing with these things. Okay. Now, the other thing that you need to take note of, right? The other thing that you need to take note of is this. This torque, what happens is this. What happens is this. So we're applying the force which is at this point. Now let me take this point as point T, or point A. And I also apply the force which is at point what? B. I also put here as point C. And I also put here as point D. So what you need to understand is that as we move from this side going this side, the torque, it is increasing. So here, the torque which is here is less. Then the torque which is here is a bit more. And the torque which is here is more. Right? But the torque on the pivot is equal to 0. So the torque that is applied at the rotation axis, it is equal to 0. So that's what we call what? Torque. And this torque, it has some conditions. What are the main conditions of torque that we need to understand? The main conditions of torque that we need to take note of, or I will say conditions of torque. The conditions of torque is, the first condition is that torque in clockwise direction is negative. So the torque that is in the clockwise direction is negative. So what do I mean if the torque that is in the clockwise direction is negative? When an object is being rotated in an clockwise, right? When an object is being rotated, right? So just imagine you have an object that is being rotated. Like, let me put like this, huh? An object that is being rotated in clockwise direction. So if I say in clockwise direction, I meant that an object that is going like this, right? That is moving in this way. That is clockwise direction. So an object that is moving in clockwise direction, like this, huh? So this object is moving in what? Clockwise what? Direction. Is what? Negative. So its torque here, it is negative, like that. So that's what we call the what? Torque in clockwise direction is what? Negative. That's the first condition. So in here, you shall see something like negative, like that. Or sometimes they write like torque negative. So that's what it means. And the other condition that you need to take note of is that torque in the counter clockwise direction is what? Positive. So torque in the counter clockwise direction is what? Positive. So if I say torque in the counterclockwise direction is positive, I meant that torque that is moving in counterclockwise direction, it is what? It is positive. So just imagine here, then here, this is where the pivot is. So meaning that the torque that is going in this way, it is what? Positive. It is moving in counterclockwise, it is positive. So the torque that is moving counterclockwise is what? Positive. So the torque here is what? Positive. So those are the main things that you need what? To take note of when you are dealing with torque. So, and torque, it goes with what we call moment of what? Inertia. So torque, it goes with what we call moment of inertia. So if I say moment of inertia, what do I mean? Moment of inertia. So moment of inertia is the rotation what? Effect that resist the rotation of an what? Object. So this is an effect that resists the rotation of an what? Object. And how do we calculate this moment of inertia? We calculate the moment of inertia by saying mr squared. So, and what are the main units? The main units are its kg meters squared. So this is what we call moment of inertia. So the moment of inertia, we calculate it by mass times radius. So radius squared, and you have to make sure that the radius is what? Squared. And that's what we call the moment of inertia. So the moment of inertia, it comes most of the time in a situation whereby you have something that is like this, right? Something that is like this, right? Now, if you look at this, you shall see something here. You have ball 1, then ball 2, then ball 3, and ball 4. Now, here, if you are rotating an object on the middle like this, and everything here is rotating, right? Everything here is what? Rotating. And here, the moment of inertia, the way you calculate the moment of inertia, it will m1r squared plus m2r squared plus m3r squared plus m4r squared. So that is the formula that we use when you are dealing with this kind of the question. That is what we call the moment of what? Inertia. Now, how about, let's change to something again. So we have the same object, but how we are rotating it, it has changed. So here we are rotating this object going in this. We are rotating this object now by using this part here, right? Let me say by using what? This part here. This. That's what we're using to rotate. So if we are using to rotate that, the moment of inertia of this, it changes. Meaning that this is M1 and this is M2, this is M3 and this is M what? 4. So the moment of inertia in this situation, it changes. How it changes? Because the moment of inertia in this situation, it will be M2r squared plus M4r squared. Why? Because the only thing that are rotating, it is this part and this part. These are the only things that are what? Rotating. M1 or M2 and M3. These are the only things that are rotating, like they're going in this way. But these ones, they are just remaining at what? Fixed point. That's why here we use this particular type of the what? Formula. And the other formula that you need to take note of, for example, for those who go to gym, they had the gymming, right? They have put their hand here and they're rotating like this, right? So in here, the moment of inertia, it will be moment of inertia equal to what? M1r squared plus m2r squared, just like that. So that's how you calculate the what? The moment of what? Inertia here. Okay. Then the other thing that you need to take note of, it is what we call the same torque, right? Now let's go back to torque. So torque is what? Force times radius. And if I may ask, what is force? Force, it is the mass times what? Acceleration. But since we are dealing with something that is rotating. Now, if we're dealing with something that is rotating, meaning the acceleration that I have to place here, it's supposed to be the angular acceleration, not the linear acceleration. So we have to convert the linear acceleration to angular. So meaning that angular acceleration here, it will be what? Is equal to alpha times radius. So what I will do is that where there is angular acceleration here, I will replace with that. So I have to say mr. So that is what? Force, like that. Then I have to say torque is equal to, where there is force here, I will replace with this. So now let me replace m alpha r times what? Radius. Then what will happen? It will be radius times radius, meaning it will be m alpha radius times radius. It is what? R radius. And this is just the same as mr squared, then alpha. Then what will happen is this part, it is the moment of inertia, because the moment of inertia, it is mr what? Squared. So moment of what? Inertia, like that. So that is what we call torque. And that is another formula that you use when you have torque. So torque is equal to moment of inertia times what? Angular acceleration. Again, torque is equal to force times the radius. Again, torque is equal to force times radius sine what? Theta. If you have been given the angle and the moment of inertia is equal to mr squared, that it is all. So if you want to access to a lot of videos, make sure you subscribe to the channel and also subscribe on the app for more things to learn. Thank you. So if you want to subscribe, make sure you comment down there, then I'll direct you what to do.